The fundamental principle of counting. In the lecture, tree diagrams and Cartesian coordinates, we study the fundamental principle of counting. And here is the statement. If a task can be completed in m ways and another task can be done in n ways, then the sequence of the two tasks can be done in m times n ways. So, but this here we talk about two tasks. What about for 3 tasks or 4 tasks, or more generally for any k tasks? So the fundamental principle of counting for k tasks can be stated similarly. So let me state here the fundamental principle of counting for k tasks, that T1, T2, T sub k be a sequence of k tasks if T1 can be done by m1 ways, T2 by m2 ways, and so on, Tk by mk ways, then the number of ways to complete the sequence is m1 times m2 times m3 up to times mk. So let's look at an example. We know Texas license plate well, right? So a Texas license plate use the format here. So this format is like 3 letters followed by 4 digits. So the letters are capital letters. Then let's look at some questions here. 1. If all letters and digits can be repeated, then how many license plate can be made? So this is, in general speaking, this will be called a repetition is allowed. So in this case, you look at, how many ways to put in the spot. So you look at a license plate has 7 spots, 3 4 letters, and 4 digits. So this spot, we look at how many ways to put in the spot. And we know there are 26 letters, so there are 26 ways to put in the spot. Similarly, this will have 26 letters to put in the spot, and this one is 26. Then this one, you have 10 digits, so you can have 10 ways to put in the spot. And then saying you have 10 ways to complete this one, and 10 ways to complete this one, and 10 ways to complete this one. So therefore, the total number of license plates we can get in this format is 26 to the third power times 10 to the fourth power. And if you punch calculator, this will give you a number for curiosity. So 26 times 26 times 26. So that one, so you get 17,576, and then times, this is 10,000. So the answer will be so if you put this, so you get 175,760,000 license plates. And let's look at the second question. If letters cannot be repeated, but numbers can, okay? So if letters cannot be repeated, but numbers or simply digits can. So how many different license plate can be made? Plates can be made. So if you look at this question again, we have 7 spots, and then see how many ways to complete each spot. Now, for the first spot, you have 26 letters to choose from. However, for the second spot, because letters cannot be repeated, so once a letter is used, then you cannot use again. Then this one has 25 ways to complete, or 25 letters available now. And now, after the first 2 letters are used, then you only have 24 letters to choose from for this spot. But however, because numbers are allowed to repeat, so this you have 10 digits, so 10 ways to fill this spot. You have 10 again, you have 10 and 10 here. So this will be, if you punch calculator for that purpose, 26 times 25 times 24. So let's look at clear. 26 times 25 times 24. You get 15,600. Then times 10,000. So this gives you 15600. You have 4 zeros from 10,000. So this would be, then you have 156 million license plates. The third case, if A cannot be used in the first spot, how many different license plates can we get? So this is similar to case 2. And so you have 7 spots to be filled with letters and digits. So this one, because A cannot be used, then you have only 25 options to complete to complete first spot. But then the second spot, we have no restriction. So we can use any of 26 letters. So we have 26 ways to complete this spot. And then similarly, we have 26 ways to complete this spot. And then the rest, we have 10 ways for each one. So therefore, by the counting the fundamental principle of counting, then we have this many. So to see that again, so you would punch calculator, 25 times 26 times 26. So you get 16,900. And then times 10,000. So your answer will be 16900, and then you follow by 4 zeros from 10,000. So you have 1,000 million. So you have 169 million license plates in this case. So if you look at these three examples, this one, repetition is allowed. And then the second case, repetition is not allowed. Well, we didn't restrict repetition for the digits, but we restrict the repetition for letters. And this one, some restrictions here applied. So this gives you an example of how do we use the fundamental principle of counting. And then the fundamental principle of counting is also known as the multiplication principle, because the total number of ways is a multiplication of product of these numbers. So it is also called the multiplication principle. Let's look at another example. And everyone has no phone numbers. So say a local phone number has the format. You have 3 digits followed by 4 digits. So a 7-digit phone number. So let's calculate how many phone numbers we have with the following restriction. How many phone numbers can we get with the following restrictions? So first case, the first digit, we know the first digit, if it's 0, then it's operator. So, and then the first digit, if it's 1, it will go to, if you push 0, it goes to operator. If you push 1, it goes to long distance. So the first digit, we need to exclude 0 and 1. Okay. So in this case, how many phone numbers do we have? How many different local phone numbers can we have? So, and then you have 7 spots here for 7 digits. So the first spot cannot be 0, cannot be 1. Therefore, you only have 8 digits. And then the second spot can be any digit. So you have 10 options to complete the second spot. And then this one, you have 10 options. So each of them, you have 10 options. So therefore, you will have 8 million phone numbers. Okay, so you have 1, 2, 3, 4, 5, 6. You have 6 zeros. So that's 8 million phone numbers. But another case, we know like 911, 800, 411, something like that. So the first 3 digits cannot be like 911 for emergency, 800 for for toll-free number, 411 for inquiries. So if the first 3 digits cannot be this, then how many different phone numbers can we have? Of course, we also need to consider 0 and 1 there. So let's include the restriction on 0 and 1, okay? So the first 3 digits cannot be this, and the first digit cannot be 0 and 1. Then how many phone numbers we have? So in fact, we just need to see how many phone numbers we need to exclude for 911, 800, and 411. So if the first 3 digits has been 911, then we talk about the last 4 spots. In the last 4 spots, you have 10 options for the spot. You have 10 again, 10 again, and 10 again. So in this case, you have 10,000 phone numbers need to be excluded or associated with 911 that need to be excluded. Similarly, for 800 number, that you need to exclude another 10,000. And then for 411, you need to exclude another 10,000. We know there are 8 million phone numbers. Now we need to exclude 30,000. So we take 8 million minus 30,000. So this becomes 7,970,000 phone numbers. And that's the answer to this question. Thank you.